Okay, so hi guys, welcome back to my channel. So in this video we are going to learn about this prototype design pattern. Okay, and this is going to be the second last video of this creational design pattern which I have started lately, and after that there is only one video left, which is Singleton pattern. Then we are done with the creational design patterns. Okay, so let's start the definition of this prototype design pattern and we'll slowly transition into the explanation and then the code. Okay, so let's read the definition, what prototype pattern actually is. So this pattern is used when creating a new object is expensive and complicated. Okay, and instead of building the object from scratch every time, we create a clone of an existing object. So this is the high level of what prototype pattern actually is. So it is used when creating a new object is expensive and it includes a very heavy computations. Okay, so it means that whenever we want to create an object, then it requires very heavy computation. So what we do is, instead of building the same object from the scratch, we create an object, okay, once, and we implement one clone method which clones the existing object, and we'll do a very small change in the cloned object according to the business use case, and we'll utilize it for further use cases. Okay, so I hope the definition is little bit clear. Okay, this pattern is used when object creation is very costly. Okay, object initialization contains many fields and configurations. So whenever we create an object, it's not about only creating an object. Okay, it's about we need to set the fields. Okay, so when we initialize an object every time from scratch, we need to set the fields and configurations. Okay, so this can be cumbersome sometime. Okay, now we want to avoid repetitive step logic or the setup logic. So this part I'll be explaining when we'll be moving further. Okay, this part. So we need many similar objects with small variations. Okay, so let's say we want to create an object person P1 which is having a property x, y and z, and x and y is common to any person. So let's say we create a person 2 which is having again property x, y and z1. So you can see these two fields are remain same across all persons. So every time we need to create an object, we are creating a similar objects with small variation. This is z1, this is z2. So these are the small variations. So this type of problems can be solved using this prototype pattern. Okay, so like why prototype pattern is introduced, let me explain you. So imagine if you're building a game engine or graphic editor. So suppose you are creating an object which requires database calls, heavy computation, large nested object creation, expensive object initialization. So whatever you have been seeing till now, that okay, object creation is simple. Okay, we'll call person P1 is equals to new person. Okay, till now this is simple, I agree, but to set the fields, it might contains the database calls, heavy computations, large nested object creations and some object initializations. Okay, so this can be cumbersome. Okay, to solve this problem, prototype pattern is introduced. Now creating such objects repeatedly becomes inefficient. Instead, create one fully initialized object like this, create one fully initialized object and always clone it. Okay, always clone it or do some changes according to the business use case and utilize it further. Okay, this is the whole idea of this prototype pattern. So what are the problems that are there before even prototype pattern exists? Okay, so let's see first point, which is the huge constructor. Okay, so now let's say we have declared one object employee emp is equals to new employee, and this is the huge constructor that we need to initialize. Like we need to pass too many constructor parameters, hard to read, hard to maintain and duplicate initialization logic. Every time we need to duplicate it. Okay, now moving to the second point, which is recreating objects again and again. If you remember this second point, which is we want to avoid repetitive setup logic, this one. So let's see. So let's say employee 1 is equals to new employee and employee 1 dot set department engineering, set country India, set salary 10,000. Now again we need to repeat the same setup. Employee 2 is equals to new employee engineering India and set salary. If you'll notice, only the salary has a variations, rest other two fields are same. So the problem is repetitive code error to prone and very difficult to maintain, okay, because as I have already told that this process may feel sometimes cumbersome in order to set the fields which are same across all the objects. We already know that factory pattern create objects, okay. If you all have watched my previous videos of this factory pattern, you all know that you all have very clear idea that what factory pattern actually is, okay. But the issue starts when objects are almost similar with only small difference. Suppose we have an employee object, okay. So factory pattern always creates an object from scratch. We are okay to utilize this factory pattern, but factory pattern we can make a small twitch in the method and we can always get the object from scratch. That is okay, that I agree. But the problem with the factory pattern is, suppose we have an employee object. Now imagine company has employee types. Without prototype pattern, you will see the factory pattern behaves like, okay, so create engineering employee, this is the first type. Create senior engineering employee, this is the second type. Create US engineering employee, this is the third type, and this is the fourth type. Till this also it is fine to create 4 types, and 4 types will give me different types of objects. That is okay. But the problem occurs, or the problem starts when the real system grows. Now the business logic says that we have these many types, these many fluctuations. So this is called method explosions. If we are okay to initialize, if we are okay to declare these many methods, then this is not feasible for a scalable system. And huge number of creation methods. Why this is happening? Because factory method creates object from scratch every time, okay. This is the problem. Even if 90% configuration is same, but still it creates the object from scratch, okay. So I hope this is clear that why we are not able to utilize the factory pattern. Now moving further, the core of this prototype pattern, okay. So what are all components that is used in order to implement the prototype pattern is the prototype interface. This is the main part. It contains the clone method, or it contains the declaration of this method, okay. This is the concrete prototype, the implementation of that clone method, okay, and the client which directly utilizes this concrete prototype methods, okay. This is the structure, this is the interface that contains clone method. This is the concrete product that utilizes, or that extends the prototype, or that implements the prototype interface and override the clone method, okay. Now before moving to the code, let's learn a little bit about the deep copy and shallow copy. We'll start with a small example. Suppose we have class address, string city, class employee, string name, okay. This is a nested class that we are storing inside an employee. Now we have created an address object, address ADDR is equal to new address, and setting the city as Delhi. Now if we want to clone, let's say we are creating an employee original. What I have said, we want to create an object once, and every time we will be cloning. So employee original is equal to new employee, and we have set the employee name as Om. I don't know who this person is. Original dot address is equals to ADDR, okay. Now what we are doing, original dot name is equals to Om, and original dot address, that will be pointing to this, okay, that will be pointing to this. Now what happens, original address is pointing to Delhi. I hope till here it is clear, okay. Now let's deep down to what is shallow copy and what is deep copy. Now suppose clone does this, cloned address is equal to original address. Now we have created a cloned, okay, and simply we have created a cloned object, and we have cloned it using a single equal to. Original is also pointing to the same address object, and cloned will also be pointing to the same address object, but we don't want. So ideally this is not what we want. We want to clone, means the new cloned object should be isolated, but here only the top level is cloned, not the nested. Now the problem is, if clone changes city, let's say there is employee 1 that contains name as Om and address as Delhi, okay. We have created a clone employee 2 that is also contain Om and city as Delhi, okay. So let's say I want to change this top level name, okay. This is the address part, this is the nested part that we have cloned. So it is possible that e2 dot set name, I want to change it as something x, so it will be crossed, it will be set to x, okay. Now if I'll do e2 dot set city to Mumbai, then this will be changed to Mumbai, and this will also be changed to Mumbai, Okay, why? Because the original and the cloned is pointing to the same address object. I hope till here it is clear what shallow copy is. Okay, now if clone changes city, clone.address.city is equals to Mumbai, the original address city also changes to Mumbai, because both reference point to the same object. Let's see why is it called swallow. Because the top level object is copied. As I have told, there will be no problem in cloning the top level object, but the problem occurs when nested objects make an entry. Okay, now we'll see the deep copy. After that, I'll be straightly go to the code and we'll be explaining two scenarios. Okay, so just wait. So now moving to the deep copy. So deep copy creates original address object 1, clone address object 2. So here we are assigning, or we are cloning the address by creating a new address and copying the values from the original one. Now memory becomes original is Delhi and clone becomes also Delhi. Why? Because this is the initial step after we have cloned. Now if the clone changes the city, clone address city is equals to Mumbai, original remains Delhi and the clone becomes Bombay. Okay, so we'll see that why the hell shallow copy is being used. Okay, what is the intention of this shallow copy and where it is being used. So shallow copy is being used if the nested objects are immutable. Okay, let's say I'll tell, let's say for this example I have P1 as Om. Okay, I don't know why I'm using this name as a person. I don't know who this guy is. Now address as Chandigarh. Okay, now we'll go to P2 some person X Y Z. Okay, and again the city is Chandigarh. Okay, the shallow copy is used if the nested objects are immutable. If let's say the complete database store the objects or the employees that belongs to Chandigarh, then we can safely declare the nested object as immutable, means cannot be changed. If it cannot be changed, then we can definitely utilize this shallow copy. No need of deep copy. Okay, if the nested objects are shared safely, if the nested objects are shared safely and it does not harm the business logic, it is okay to use the shallow copy. And heavy to duplicate, if the nested objects are heavy to duplicate, okay, then we can use the shallow copy. So these are the 3 points where shallow copy is intentionally used and shallow copy may be acceptable. So let's see the code for which we are waiting so long. Okay, so as I have discussed the architecture or the components of this prototype pattern, this we already know this is an interface. Okay, this is having one method which is clone. Okay, the return type of clone is prototype. Soon you will get to know why we have returned the type as prototype. Okay, now we'll move to, so this employee implements the prototype. We have the 3 instance variables and we have one constructor which is initializing all the 3 variables. We have this employee clone which is overridden. Okay, now we have overridden the clone method here, okay, in this employee, and simply a setter method where we want to set the name, and this is the show details, which is nothing but we can utilize it or we can override the toString method, but that is okay. Okay, so now this is the main method of this prototype pattern. So what we have done initially, we have declared one object as employee. This is the main, or this is the original employee that we have declared. Now what our discussion, based on our discussion, what we have discussed is, like every time we'll create one new object, and every time when we want some other object with small variation, we'll clone it. Okay, so employee, cloned employee is equals to original.clone. Okay, now let's go to this method original.clone. So original type is employee.clone. Let's move here, employee.clone. So what it is doing, it is creating a new employee. Let's say this employee has name Om engineering and its salary. Okay, now here we are copying the same value, name, department and salary, and returning the new employee. So the new employee will be returned in this or stored in this employee or cloned employee, but we don't want the name to be same as Om. So we have done cloned employee.setName. We have utilized this setter method, okay, which we have created. We have set it to current. Now we are printing the original which original.showDetails and clone.showDetails. So original will look like Om, department engineering, salary this. Cloned Karan, which we have set here, Karan, and department is engineering, salary is this. Okay, I hope this is clear. This is the basic part. This is the basic example where nested object is not came into picture. Okay, now we'll move to the code where nested object is in the picture. So let's see the code. So interface prototype extends clonable. Okay, so this is the class clonable. Now prototype clone. Again, this mystery is yet not solved. Why we are using this prototype? Soon I'll be explaining, which I have also not explained in this part. Okay, this part, why the return type is prototype. I'll explain you in this code example. So now I have declared one address which implements this prototype. So address contains the instance variables, constructor, the clone method which is overridden just because we are implementing the prototype, and prototype contains the clone method. Now we have used the toString method to override. Next, what we have done, we have declared one more class person which implements this prototype. We have the instance variables, we have the constructor with us, we have the clone method which is overridden. Why? Because we are implementing the prototype. Next, we are overriding the toString, which is nothing but printing the name and address. Can you see here? This is the nested object which we are using. Address is inside the person. So this is the perfect example to understand how cloning works inside the nested object. Let me increase and let me erase and let me clear some of the spaces. So this is the main method, and again based on our discussion what we have discussed, only one time we'll be creating an object. Okay, and next time if we want the same object with a small change, we'll be cloning it. So what we have done here, we have declared one person P1, new person, the name is Om and the address is Delhi. Okay, the name is Om and the address is Delhi. Now if we want the second person, what we are doing, P1 dot clone. What is the data type of this P1 person? And we are calling the clone. Let's get into the clone of person. Here we are inside the person and we are calling the clone method. Let me erase this. So this is the clone method where we are actually or currently in, because we have called p1.clone. Now we are here. Okay, so what this clone method is doing, this method is the actual implementation of the deep copy. Okay, so what we are creating, person copy here, person copy is equals to super.clone. Okay, let me tell you one concept. So whenever we declare a class, so on the backend side, it by default extends the objects from where this toString is coming, from where the hash code is coming, and from where the clone method is coming. Okay, so the objects have this implementation of toString, clone, hash code. If we want the default implementation, we do not touch it. If we want these methods to be work as our business logic, we override it. Okay, I hope this is clear. So now class person implements prototype. Okay, so person copy is equals to super.clone. What this super is? Super is always used to call the immediate parent method. Okay, so as I have told you that person is extends object. So super.clone means object clone we are calling. I hope this is clear. So when we call this object clone, we will get the new person or P2. Okay, and we store P2 as a copy. Okay, the return type is person here. Okay, now let's move forward. This part is the deep copy. Let me remove this and we'll tell you. This part is the deep copy. We haven't stopped here. Okay, we haven't stopped here. Why? Because if we are stopping here, then it means that the top level will be cloned, but the nested object is remain untouched. Means the original and the clone will be pointing to same address object. Okay, so we don't want it, we want the deep copy. So what we are doing, we are calling the address.clone. Let's move to the address.clone. Address here is address, so we are moving to address.clone. Let me remove something. Okay, let me remove this. So here we are in the address class and here we are inside the clone. So what we are doing, return address super.clone. Again, this address class is also extending that contains the clone method that contains the clone method. So super.clone, from where we are actually calling the clone address.clone, from where this address is called person, okay, p1.clone. So p1 has the property of name as Om and address as Delhi, okay. So now name as Om and address as Delhi. Now address.clone, now address.clone, address has the city as Delhi, okay. Now we are returning one address object because because we have called the object clone, it will return us the new address object with the property as same as what we are calling from the original object. Just because we have called the super.clone which is coming from the person.clone which is coming from the p1.clone. So p1, all the properties of p1 will be coming to person, okay. I hope this is till here it is clear. So now we have called address.clone, so all the properties of this address which is coming from the p1 will be coming to the address class. Now we have called super.clone, so address properties will be cloned and we are getting the new address object. I hope this is clear. So again we'll come here, address.clone will return the new address object with the properties that from where we want to clone it, okay. So now this person copy dot address is equals to new address object with the property as Delhi, okay. And finally we are returning the copy object, okay. So finally we are returning the copy object and we are storing inside the person p2, okay. So now the question is why we are keeping the data type as prototype clone. Why? Because sometimes this clone is returning the address object, sometimes it is returning the person object, but we want to make it generic. So if you haven't watched my solid principles, you can go and watch. This concepts will be very clear, okay, after watching that video. There are 2 videos on my playlist. So we can store the clone object, okay, we can store the class, okay, inside the interface just because it is implementing this interface. I hope this is clear. So this is the generic data type which I can keep here in order to store the address or in order to store the person, just because they are implementing this interface prototype, okay. For more details, please go and watch that solid principles part 1 and part 2, okay. Now we are moving to next part. We are printing the p1 and we are printing the p2. So till here, till this point, name is Om, city is Delhi. Till here, p2, name as Om, city is Delhi. We want the p2, person 2, name as Verma and set it to Mumbai. Now if we print here, the p1 name is Om and Delhi, the p2 as Verma and Mumbai. I think I know this person, Om Verma, okay. If you all also know, please comment it down, okay, just joking. Now we'll see the output. In the output, if you'll see here, so original Om lives at Delhi, clone Om lives at Delhi, we are printing here. As I have told you, this is the output. Now after modifications which we have done here, okay, now our output becomes Om lives at Delhi, Verma lives at Mumbai. I hope this is clear. I hope this is clear and I was able to explain this code, the complete explanation, how the flow of the code is working whenever we call this or the implementation after this. So in details, okay. So I hope this is clear, okay. So let's move to one more concept which is not actually related to this prototype pattern, but yes, we can discuss in this video, okay. So if you'll see Spring Singleton versus prototype, there is, if you would have worked on Spring Boot, you definitely would know that there are the bean scopes which is Singleton or prototype, okay. The main work of this prototype is same, but the inner implementation vary from what is there in the prototype pattern. So here comes the important Spring concept, okay, which is the Spring bean scope. We have scopes defined in this Spring which is Singleton and prototype. Singleton scope is the default, okay. So if we have annotated @ component for a class, then Spring creates only one object, entire application uses the same object, okay. If we are annotating @ component, that means that this class object is managed by Spring and Spring will create only one object, and throughout that applications that single object will be circulating, okay, everywhere wherever we are using this auto-wired keyword, okay. I hope this is clear. So let's say we have created a class user service which is annotated as component, and in some other class we want the object to be injected which is known as the dependency injection, Okay, this is the Spring Boot concept. So user service which is annotated at override will get the same object which is created at the start of the application. Okay, I hope this is clear. Now comes the prototype scope. This is not the default one. Okay, so if we want this scope to be prototype, we need to do some configurations. Okay, so @component is the basic one. @scope, which is prototype, this we need to define for if we want the user service to be behaved as prototype. Now what is prototype here is, now Spring creates a new object every time requested. Okay, the concept is same, the prototype used there in the pattern and prototype here, we are getting the new object with deep copy. Okay, here also the concept is same, but the implementation is very different. Okay, now the Spring creates a new object every time requested. So every time we are doing auto wired in some Y class, we are getting the new object. If you will do get bean, you will get a new object. You will do get bean, you will get a new object. So every time request get a fresh object. Example, this is the application context which maintains all the Spring beans. Okay, now what we are doing, user service u1 is equals to context.getBean. Okay, from this context where all the objects are getting stored, so we are having context.getBean. If we want the bean, so user service dot class. Okay, this is the process through which we have extracted what beans is stored, which beans is stored inside the application context. So similarly, we have done user service u2 is equals to context.getBean. Again, we have called user service dot class. Now every time we have called u1 and u2, for singleton result, the same object will be returned. So if we'll do u1 double equal to u2, we are asking that is u1 double equal to u2, means that the reference are same. True, means for the singleton pattern, we are getting the same object throughout the application. Now with the prototype pattern, so every time we are calling the get bean, we are getting the different object. So that's why it returned false, means u1 and u2 are not same for the prototype case. So Spring prototype scope is not prototype pattern cloning internally, means the internal flow can be different, but the intentions are same. Okay, now internally how Spring's singleton works is, this is the extra part that I am explaining. Please bear with me. So during the startup, Spring container starts and it scans all the components, means all the class that is annotated with @component, and it creates a singleton beans. Okay, and store it in the cache. This is the data type which is used to store the beans. Now user service, this keyword is used based on the class name. So user service, which is the name of the class, and the object string and object. Order service, which is the name of the class, order service object, again string and this object. Whenever bean requested, Spring return from the cached object. Okay, now let's see how this prototype works. So Spring does not cache a prototype beans. Okay, whenever you will do get bean user service dot class, it does create a new object, ingest the dependencies, return object, and forgot that object. I hope this part is also clear. Like if it would help, if you would have worked on Spring Boot, it will definitely help to clear out some basic concepts in order to start working with @AutoWire, @component, the scope of the bean. So I hope this is clear, and the main intention, which is to explain the prototype pattern, is also clear. So next video will be on the singleton pattern. Till then, thank you for watching and having patience, and thank you. So see you guys then in the next video. Thank you.